Okay, so the next thing we have to go over has to do with the little box that's at the top of your periodic table, and it's entitled the Table of Common Polyatomic Ions. Okay, kind of on the left-hand side there above the metals. Okay, those are special molecules that can exist, but only as charged particles. Any charged particle is referred to as an ion. That's why ionic compounds are named that way. Okay? In an ionic compound, you always have a positively charged metal and a negatively charged non-metal. Okay? In some compounds, though, you can have a positively charged molecule, okay, with another negatively charged molecule, if it was to go that way. Okay? That would be something that contains polyatomic ions. Right? So as an example, I could have this compound here. Okay? How many elements are in that compound? Three. Sodium, oxygen, and hydrogen. Okay? As soon as I see a compound that has more than 3 elements in it, if it starts with a metal, I know it's got a polyatomic ion in it. Okay? So, looking at this, okay, I want to start out the naming process with the thing I'm sure of. That would be Na, or sodium. Okay? Since there are 2 more elements here, I want to look on my table of polyatomic ions and see if I can find something that looks like this, O with H. Okay? Do I have anything on that table of polyatomic ions that looks like that? Okay, what's it called?
Hydroxide.
Hydroxide. Okay, so OH is called hydroxide. So this stuff is sodium hydroxide. Okay, the naming process is actually pretty easy. You just write the name as it appears there in that box. Okay, you don't have to worry about changing that name in any way. You write it exactly as it appears in that box. Okay, if it ends in ite or ate, that's fine. You write it that way. Okay, you don't change those names at all. Okay, so that would be sodium hydroxide. Okay, what would this stuff be?
Lithium hydrogen.
Okay, yep. Right, so the Li stands for lithium, and NO3 is in that table of polyatomic ions. Its name is nitrate, lithium nitrate. All right. All the other rules that apply to ionic compounds apply to these, okay? Including if you had to use Roman numerals. Right? So, for example, if I had this stuff, okay, this stuff is going to be copper. SO4 is sulfate. Okay, but copper has more than one possible charge. Okay, so what's the charge according to your little table there on sulfate? -2. Yeah. Okay, so sulfate's charge is -2. Here's where it gets tricky. How many sulfates are there? 1. Every sulfate molecule has 1 sulfur and 4 oxygens in it. It can be misleading. That's exactly why I put this one up here. Okay, sulfate is SO4. That's 1 sulfate molecule. It contains 1 sulfur and 4 oxygens, but there's only 1 sulfate here. Okay, everybody follow me there? All right. Now that has a charge of -2. So what's the charge on copper got to be? +2. This is copper 2 sulfate. Okay, little blue crystals. We'll actually use them in our lab. All right. Now, other hairy things that can happen with these polyatomic ions. Okay, What if I give you this name and ask you to write the formula instead? So I'm going to write this out here, and we're going to call it magnesium nitrate. I want to write the formula for that. Okay, so if I want to write the formula, what's the formula for magnesium? Mg. Okay. What's the charge on magnesium?
+2.
+2. Okay. What's the formula for nitrate? NO3. Okay, and the charge on nitrate is -1. Now what do I have to do when I'm making ionic compounds? What do I do with the charges? Drop and swap. Okay, here's where it gets crazy. Okay, obviously the 1 goes here, and we don't write ones. Okay, so the 1 is gone. Where does this 2 go? Okay, so if I drop this 2 down here and I write it right here, what am I now saying?
32.
I have 32 oxygens and 1 nitrogen. Is that what I want?
No.
No. I want to say there are 2 nitrates. So I do this. I just put brackets around it, just like you would in math. Now that 2 multiplies everything in the brackets. There are 2 nitrates now, as opposed to 32 oxygens, which is a lot different. Okay? So that's something new. Okay? You wouldn't have learned that in grade 9 science either. Okay? Polyatomic ions are something new to grade 10. Okay? So the naming part of them is pretty easy. You just write their name exactly as it appears in the box. Writing the formula still involves doing the drop and swap, but occasionally will require brackets. Okay? These other ones that we looked at didn't require brackets. Okay? Because I wasn't putting another number beside this one. Okay? So I didn't need brackets on that one. Okay? I didn't need brackets on this one, and I didn't need brackets on sodium hydroxide either. Okay? Unless I'm putting another number beside it, I don't need to enclose it in brackets. Okay? I know I'm throwing a lot at you here. Okay? This is all new stuff. Okay. Questions on how the polyatomic, should we do another couple where we're making the formulas? Okay. Let's try. Okay, let you try those two. Give you a couple minutes here. Okay, let's look at the first one. All right, so formula for sodium is Na. And what's the charge on sodium? +1. Okay, and then sulfate is SO4, right? And its charge is -2. All right, so now that I've got those charges there, now I drop and swap them, right? So 1 will drop over and go to the sulfate, and I won't write it, so I won't need it, okay? And the 2 will drop and come over to the sodium. Okay? Done. Na2SO4. Okay? Don't need brackets on that one either, because that number doesn't apply to the sulfate. All right, now this one is about as tricky as they're going to get, because it involves both a multivalent metal and a polyatomic ion. Right? So the 2 tricky things that we learned today. Okay? So lead is Pb, and what does the Roman numeral tell me? It's the 2 plus charge. It doesn't tell me there's 2 of them. That's a very common mistake. It tells me to use the 2 plus charge in my drop and swap. Okay? And then nitrate is NO3, and its charge is -1. Okay? So now when I drop and swap, the 1's going to come over here with lead, and I won't write it, and then I'm going to need to put a 2 here. Okay? But as I said, we're going to need to enclose that in brackets. That's lead to nitrate. Okay? So very, very common mistake, guys, that I see. People interpret this Roman numeral to mean there's supposed to be a 2 here, and there isn't. Okay, that Roman numeral tells you what charge to use in your drop and swap. All right, questions on those? Okay, I'm going to give you maybe about a 5-minute break here because we've been going pretty hard. Okay, and then we'll start on molecular compounds after that. Okay, so if you need to go to the bathroom, get a drink, something like that, do it now.